For number 4, I'm going to use a separate sheet of paper so I can graph this out a little bigger since there's not much room there. First, I'm just going to draw a quick graph. Doesn't have to be anything beautiful. On your EOC, you'll be provided graph paper. On your test, I provide you regular sheets of paper, but if you have your own graph paper, you can use it. Or if there's graphs already on there for another question, you can use those and kind of try to graph this onto this graph if you need to. So number 4, a triangle ABC has vertices at A is -1, 9, so we go over to -1 and up to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So at 1, 9, that's A. B is at 3, 5, so 1, 2, 3, goes up 1, 2, 3, 4, 5. That's our B. And C is at 5, 7. So 5 and goes up to 7. That is our C. So here we have our triangle ABC. Classify the triangle according to side lengths. So we can already look at this triangle and kind of see that there's no side lengths that are equal to each other. This one is a tad longer than that one, so it would be scalene. And we can also tell by our graph that none of these angles are obtuse angles because they would be greater than 90, which means they would kind of look like that. There's no right angles, which are perfect 90-degree angles. And none of them are perfectly the same. So it's just an acute triangle. If this line had been more like this, where those would be perpendicular lines, then we would have had a right triangle. If they were a little farther away like that, you would have had an obtuse. But for now, it's just scalene and acute. For number 5, it says that 2 students describe the transformation below. Choose who is correct. Now, by choosing who is correct, they both could be correct, they both could be incorrect, or just one of them can be correct, and that's what we're going to look at. So just because you find that one's correct doesn't mean the other one is incorrect. You still have to look at their work. So Bailey says that the 2 triangles are congruent because they are reflected across the x-axis. Well, this is our x-axis. So it should be perfectly reflected. So this point is 2 above, this point is 2 below. That's good. This point is 2 above, and this point is 2 below. That's good. So then this point is 1, 2, 3, 4 above, and 1, 2, 3, 4 below. So Bailey is correct. It was reflected across the x-axis. Now we're going to look into what Mina says. Mina says that the 2 triangles are congruent because the bottom triangle was translated 4 units up and then rotated about 0.2 or 2 onto the on top of the triangle. So first 4 units up, 1, 2, 3, 4, that would make this triangle here, 1, 2, 3, 4. That would make the triangle look like this. So far it looks pretty good. Now to be rotated about 0.22 would be this point here. So this point's not going to move, but the other sides are going to move. So if we were to rotate it, it would kind of look like this, which does not match up. So Mina is incorrect.